Good morning, friends. Again, we will be continuing with the basic concepts of Verilog. And one of the important concept is the system task and the compiler directives. Okay. System task and compiler directives gives information about the a program time. We will be observing different system tasks provided and how to utilize this system task in our Verilog program and what are the beneficial for those things. Okay. So first we'll start with the system task. So Verilog provides standard system tasks for certain routine operation. Okay. All system tasks appear in the form of keyword, which it is there is the dollar followed by the keyword which we are going to use. Okay. So what are the different types of keywords for the system task that also we will be using. But whenever you observe a dollar symbol, then we should understand that is relating to the system task or a compiler directives. Okay. So that we are going to observe. Okay. So some of the operations such as the displaying on the screen, monitoring values of nets, stopping and finishing are done by the system task. So as I said, so when I wanted to display something onto an hardware, okay, so that you can display by using the keyword dollar display. When I wanted to monitor some of the variables, so I can use dollar monitor. Okay, if I want to start the functioning of the operator, or I need to measure the time. So that also you can do. You can stop also, you can finish also, you can end also. Because when we are writing a program, if our program enters into the infinite loop, so then what happens? I need to stop it. I need to finish that task. So these system tasks will be plays a vital role during those circumstances. Okay. So that is why these system tasks are very much vital. Okay. Similar to the compiler directives also. Right. So first system task which we will be knowing is about the displaying the information. So I wanted to display how many variables are present in the program. So what I will do is a dollar display. So dollar display is the keyword, is the main system task for displaying the values of variables or strings or expression. This is one of the most useful tasks in the Verilog. So which how many variables are there in my program? I want to display only around 3 to 4, or I wanted to display complete. So I can use dollar display within parentheses P1, P2, P3, so on, Pn. P1 is nothing but process one you can tell, program one you can tell, right, whichever string you wanted to display, so that you can be displaying. If you have observed that in the ATM also, you are getting different sets of messages. Is it or not? If I take a mobile phone application also, when I make a call, if call connects, then fine. If call doesn't connect, so it may be busy. It may be in a remote location, or it may be mobile is switched off, but it is not reachable. So these are the different sets of messages which you are going to observe. And these things will be displayed by using this display system task. Okay. So P1, P2, P3, and Pn can be quoted string or variables or expression. Dollar display within without any argument produces a new line. Okay. Some of the displaying the things and their formats you can observe here. So you will be writing in a program percentage D or percentage capital D. So display variable in a decimal. Okay. Percentage B or percentage capital B. Display variable in binary. Percentage S display string. Percentage H display hexa value. Percentage C display ASCII character. Percentage M hierarchical name. Percentage V display strength. Percentage O variable in octal. Percentage C display current time. Percentage E display real number in scientific format. Percentage F display real number in decimal format. Percentage D display real number in scientific or decimal, whichever is shorter. So these are the different values which you can observe using the system task, which we can observe in our main program also. So here you can observe that dollar time. Okay, this is one program where they have written dollar display time. So whatever time it will be executing at that particular time, it will be displayed. So here percentage B, the values will be displayed in the binary format. Okay, percentage B also, here also you can observe it will be displaying in the binary format. Right. So next, if I want to display some special character, so for that also you will be using same dollar display. This is a new line, multi-line. So how your output will be? This is a next line. It will be multi-string with a percentage sign. Percentage display the special characters. So these are some example which you can find in displaying the things. Because always you observe that displaying should be in a particular order so that it can be easily understandable by the other person. So in that way you need to display. Otherwise, that is why you will be using a tab. That is why you will be using a new line. That is why you will start in a justification thing. All those things it will be very easy. Right. This is the first system task which I have used. Now second system task is here monitoring information. So Verilog provides a mechanism to monitor a signal when its value changes. So we have seen multiple variables, right? And these variables values it will be keep on changing, and that I need to observe it, right? And to do this one, the keyword which I'm going to use is the dollar monitor, and I'm going to give what is the task which I'm going to be used. So again, I'm taking same process one, process two, process one. So dollar monitor continuously monitors the values of the variables or signal specified if the parameter list and display all parameter in the list wherever the value of one variable or signal changes. Only one monitoring list can be active at a time. If there is more than one monitor in the your simulation, the last dollar monitor statement will be a active statement. Okay, so you can use this one. Two tasks are used to switch monitoring on and off. So dollar monitor on, dollar monitor off. So dollar monitor time, okay, dollar time values. So it is going to check all the time parameter and it is going to display in the binary value for this value. And when it is display changing the value, it is going to intimate us. Okay. So dollar display, dollar monitor. Then if the program is in infinite loop, then I need to stop it. Or if my program is all processes completed, so I need to end it. So we are having the keywords of dollar stop and dollar finish. So the task dollar stop is provided to stop it during a simulation. Usage is dollar stop. There is no password because wherever the module you are going to write, if you just write dollar stop, it will stop executing your program. Dollar finish indicates and it will terminate your simulation part. So the keyword for use for that one is what? Dollar finish. Okay. So this is one simple example which is given for execution of stop and finish part. So these are the major four system tasks which is available. Next type is your compiler directives. So compiler directives, why it is used? Because so already we have defined few of the compiler directives. Still, if I want to define my own directives, so that is also available. Why? Because this Verilog is a open source. So how you are going to define your own compilers? So you have to go with a dash symbol followed by the keyword. So this is a syntax which you have to use for using the compiler directives. Okay. So here two most useful compiler directives we are going to use. One is dash define and one is dash include, which is this value. So dash define, why you have to use is that, so in my program I want to define some particular value. Suppose say pi equal to 3.142, that I want to define. So I can define a value here. I want to define a register value of length, so that you can utilize by defining these values. So how we are going to define? You have to use dash followed by a define keyword. So it will do the defining of those things. The dash define directive is used to define text macros in the Verilog. So you can observe that a dash define word size of 32 it will be displaying, and stopping also you can use. One more is your hash include, dash include. The dash include directives allows you to include entire content of a very long source file in the another file. So I am writing one program, some subprogram is required. So already it has been there that subprogram. What I need to do is I need to call. So what I will do, I will write compiler directives dash include. So that subprogram will be included in my program. So you're saving lot of time. So that is what you can observe here. So in the system task, you are learning about the display, monitor, stop, finish. And in the compiler directive types, you are learning about define and include. Okay. So you may be expecting one question from the exam point of view. Okay. So next module part, we will continue in the next session. Thank you.